Good morning all. In today's class on analytic geometry, we'll discuss polar subtangent and subnormal. So you let r equal to f of theta be a polar curve and let p r theta be a point on the curve. Let the tangent and normal at P of the curve meets the line through the pole perpendicular to radius vector. So that line is perpendicular to the radius vector. Radius vector OP. So the tangent and normal at P of the curve meets the line through the pole perpendicular to the radius vector OP at T and N respectively. Then OT is called the polar subtangent and ON is called the polar subnormal. So we can draw all these things. You consider a polar curve r equal to f of theta. And you consider a point P r theta on the curve. Suppose that O is the pole. So this point is the pole. Now you can draw OP. So you draw OP. So this is the radius vector r, its length is r. So this is the radius vector OP. Now you consider the tangent and normal at P. So this is the tangent at P and you consider the normal at P. Consider this, this is the normal at P. Actually extends to both sides of P, but we require this much part. So you consider the line which is perpendicular to the radius vector. This is the line perpendicular to the radius vector. Draw that line. So this is the line perpendicular to the radius vector. So you know that this is 90 degree. Suppose that this angle is phi. The angle made by the radius vector with the tangent is phi. Then suppose that the normal meets that line at N and the tangent meet the line at T. Then the distance OT is called the polar subtangent. This distance ON is called the polar subnormal. Now from triangle OPN, you know that this angle is 90 minus phi. Suppose that this angle is some theta. So from triangle OPN, 90 plus 90 minus phi plus theta equal to 180 degree. So this implies you can cancel 180. So this implies theta equal to phi. So this angle is actually equal to phi. And from our previous discussion, you know that we have tan phi is equal to r d theta by dr. Now you consider the triangle TOP. From triangle TOP, we have tan phi equal to OT by OP. You can see that tan phi is OT divided by OP. And so this implies tan phi is equal to OT divided by OP is R. So this implies OT equal to R tan phi. And you know this is R into, tan phi is R d theta by dr, R d theta by dr. Therefore, so this implies OT equal to R square d theta divided by dr. So this is the polar subtangent. Now you consider the triangle PON. So from the triangle PON, we have cot phi is equal to ON by OP. ON divided by OP is cot phi. So this implies cot phi equal to, OP is R. So this implies R cot phi equal to ON. So this is equal to, this implies R by tan phi is equal to ON. So this implies ON equal to R into 1 by tan phi is 1 by R into dr by d theta. Tan phi is d theta by dr. So it is 1 by R into dr by d theta. This implies ON equal to dr by d theta. So this is the polar subnormal. So this distance is the polar subnormal and this distance is polar subtangent. So you have ON is dr by d theta and OT is r square d theta by dr. Therefore, polar subtangent at any point r theta is r square d theta divided by dr, and polar subnormal at any point r theta is dr by d theta. We do a problem. Question: for the cardioid, R equal to A into 1 minus cos theta, find A, polar subtangent at r theta, B, polar subnormal at r theta. Solution. We have polar subtangent is r square d theta by dr. Here r equal to a into 1 minus cos theta. So this implies dr by d theta is a sin theta. Therefore, r square d theta by dr is r is a into 1 minus cos theta, a into 1 minus cos theta the whole square into dr by d theta is a sin theta. So d theta by dr is 1 by a sin theta. So this is equal to a square into 1 minus cos theta is 2 sin square theta by 2. 2 sin square theta by 2 the whole square into 1 by a into sin 2 theta by 2. So this is equal to a square into 4 into sin raised to 4 theta by 2 into 1 by a into 2 sin theta by 2 cos theta by 2. So that is equal to, you can cancel a into 2 into sin cube theta by 2 divided by cos theta by 2. So this is equal to 2a sin square theta by 2 into sin theta by 2 by cos theta by 2. So that is equal to 2a sin square theta by 2 into tan theta by 2. So this is the expression for polar subtangent to the curve r equal to a into 1 minus cos theta. Now polar subnormal at r theta is dr by d theta, and you know that this is equal to a sin theta, because we have dr by d theta is a sin theta. So this is the polar subnormal. So we may illustrate this, or we may verify this using a GeoGebra. For that, you consider the cardioid r equal to 4 into 1 minus cos theta. So find the polar subtangent and polar subnormal. At r is 4, theta is pi by 2. So from our calculation, you can see that polar subtangent is, it is 2a sin square theta by 2 into tan theta by 2. So this is equal to 2 into a is 4 into sin square pi by 4 into tan pi by 4. So this is 8 into sin square pi by 4 is 1 by 2, 1 by root 2 the whole square into tan pi by 4 is 1. So this is 4. And polar subnormal at 4 pi by 2 is A sine theta, A sine theta. So this is A is 4, sine theta is sine pi by 2. So this is 4. So we may verify this using GeoGebra. So you consider the cardioid R equal to 4 into 1 minus cos theta from 0 to 2 pi. Theta varies from 0 to 2 pi, and you mark the point 4 pi by 2. So this is the point 4 pi by 2, A. So you may rename that as A, as P. So this is the point P. And you know that the radius vector is OP. This is the point O. So O is the pole and OP is the radius. Now you draw the tangent at P. So this is the tangent at P, and you may draw the normal at P. So this is a normal at P. Now you consider the line passing through the pole perpendicular to the radius vector OP. So that is this line, the axis, entire x-axis. So draw the line perpendicular to this and passing through this. So this is that line. So this is the line perpendicular to OP passing through the pole O. Then intersect the tangent at P with the line. So intersect these two lines and this. Then this point is the point T. Then OT is called the polar subtangent. In this case it is x-axis. It need not be the case always. This distance is OT. And intersect normal at P with the line perpendicular to OP. So this is N. Then ON is called the polar subnormal. Then you can see that the distance ON is 4 and the distance OT is 4. So it is evident from the figure itself, or you may measure the distance. Distance OT is 4, distance ON is again 4. So this is what we have obtained from our example. Now you may consider another point. See what is the polar subtangent and polar subnormal. So you consider this point, any point on the curve. Consider a point, suppose that this is the point P. So its polar coordinate is R is 7.35, the angle theta is 146.82 degrees. Suppose that this point is the point origin O. Then you draw OP. So this is a radius vector, so which makes an angle 146.82 with x-axis, and radius is 7.35. You may measure that, or it is given here. Okay, so you can measure this angle. and you consider the tangent at P. So this is the tangent at P. And you consider the normal at P. So this is the normal at P. Now you draw a line perpendicular to OP. So this is the line perpendicular to OP. Then, so you may. Then the normal meets the line through O at this point, intersect this line with this one. So this is N. And you intersect this line with this one. So intersect this with this. So you can see that it is the point this. So this rename that as P. Okay. Then this is the polar subtangent OT, and this is the polar subnormal ON at the point P, at this point P. So you measure that distance you can measure. So OT is 24.67 and ON is 2.19. So you may verify this using our numerical methods. You can use calculator. Okay, that's all for today. Have a nice day.